Hey guys, and welcome to your next tutorial. In today's tutorial, we're going to go over rotations. Now, this is something we haven't done yet. We need to be able to rotate our sprites in-game. Now, for our background sprites, we probably don't need rotation. All the tiles and things can be oriented the same way. But for our player and our zombies and our humans, they need to be able to have arbitrary rotations if we want to have more detailed sprites. Now, before, we only had just regular circles, which you'll see right here, the circle.png, that has no detail or anything like that, so we didn't need rotations. But I've added three new textures, human.png, zombie.png, and player.png, that do have some, big eyeballs and things like that are going to need to be rotated in a specific direction based on which way that agent is facing. So the math for this is actually really, really simple. I'm not going to go super into detail because you can easily, look up how exactly the math works online. But say we have a point here at the top right. What we're going to be doing is rotating this point around the origin, because that's the easiest thing to do. Now, the origin is where x is 0 and y equals 0. So if we wanted to rotate it by 180 degrees, we would end up rotating it through the origin like this, and it would end up on the other side. If we wanted it to rotate 90 degrees, we would rotate over here at a 90-degree angle from the original position. And if we wanted to rotate 270 degrees, we would rotate it over here. And you can, figure out everything in between. We're basically just taking this point right here, and we're kind of rotating it around the origin in a circle. And we can use this to rotate our sprites. We'll basically just rotate each of the four vertices around the center of the sprite, which we will treat as the origin. Now, the code, or sorry, the math to rotate this point around the origin is actually really simple. It's just a little bit of trigonometry, and you can totally Google this and learn exactly why it works. But the formula is new x equals old x times cosine, and we're going to say angle here. Let me make this a little bigger. Minus old y times sine angle. And new y equals old x times sine angle plus old y times cosine angle. And that is the very simple formula for rotating a point, old x, old y, about the origin by angle. Now we're going to be using radians instead of degrees, which means if we wanted to convert degrees to radians, we would just multiply by pi over 180. Hopefully you are familiar with that. And let's see, what else do we need? Well, there's one more thing we need, one more little magic equation, and that is figuring out an angle from a vector. So here is our player right here, and we're going to say this is the default direction, is pointing to the right. That's the conventional one usually, I think, is aligned with the x-axis. So this is when angle is 0. When angle is 90, he's going to be facing this way. When angle is 180, he's going to be facing this way. When angle is 270, he's going to be facing this way. And of course, we will treat that as radians, not degrees, even though I'm talking to you in radians or degrees. So if we want to rotate based on the vector he's currently pointing at, because if you remember, right now all we do is we keep track of the direction that the player is pointing and the velocity that the humans are moving at. So what we need to do is take this vector that is their direction and determine the angle from the x-axis right here. So we need to determine this angle right here. Oh, let me get the pencil tool, this angle. If we can determine that angle, then we can rotate the sprite by that angle. And now this is actually really, really easy to do. What we need to do is use the dot product of vectors. Now, the dot product is simply taking the components of each of the vectors and multiplying them together. So if we have a vector a and b, then the dot product is a1 times b1 plus a2 times b2. We multiply each of the components together and then add them all together. So a1 would be the x component, for instance, and a2 would be the y component for vector a, and likewise for b. So using the dot product, with a handy little formula, we can determine the angle. So if we call this angle, I don't know, we'll call it z, then what we'd say is cosine of z equals the dot product of a and b, and in this case we'll say this is a and this is b. That works. So it's going to be a1 times b1 plus a2 times b2. And then finally we divide by So I need to draw a little line here. Click. Then we divide by the length of A times the length of B. So we'll say LA times LB. Now, luckily, for our direction vectors, the length of A and the length of B are going to be 1 because they are normalized. Remember, a normalized vector always has a length of 1, so we can completely forget about the bottom here because 1 times 1 is 1. If you divide by 1, you get the same value, so it's not even important. And so this is our final formula for determining that, well, it's not the final formula. We have to do a little bit of algebra here to change it so that we have just z by itself on the left side. And to do that, we say z equals a cosine a1 times b1 plus a2 times b2. Now, a cosine stands for arc cosine. It's the opposite of cosine. So if you're familiar with algebra, as you should be, all we have to do is move cosine to the other side, basically, using the a cosine function. And this is our final formula for determining that angle. So using this formula up here for actually rotating the point, and this formula down here for getting that angle from our vectors, we can actually rotate our sprites. So let's go ahead and get to work. That's enough talking. First thing we need to do is stop using the circle texture for everything. So right now in agent.cpp, all of our agents use the exact same texture. That's not really what we want to do. Instead, what we want to do is allow each agent to specify its own texture. So let's go into agent.h and add a new variable. And we're going to say gluint, and we'll say mTextureID. And this will be the texture for that agent. And we'll come back in here. And we're going to basically just copy this part right here and put it in human, zombie, and player to pick the texture that we need. So in player, we're going to change this to mTextureID equals the engine resource manager, so we need to include resource manager up here. There we go. And instead of getting the circle.png, we're going to get player.png. Let's go ahead and copy this, and we'll go into zombie.cpp and go to its init function. And this is going to be zombie.png. And again, we need to include the resource manager. And while we're at it, let's make sure the color is solid white, because we don't want to apply another color on top of our texture. We need to make sure we do the same thing in player as well. Color should be white. And finally, we need to go into human.cpp, into his init function, and do the same thing. This will be human.png, color will be white, and we need to include resource manager. Like that. Alright, so now all of our three different types of agents are going to have their own little sprites. So we can get rid of this static texture ID here. And instead, we're just going to use mTextureID. Alright, so let's see what that looks like. I'm going to go ahead and run it. And actually, let's zoom in a little bit. I believe we are zoomed out by 4 times. Let's zoom out by only 3 times instead. So I'm going to change camera scale in the game loop to 1/1/3. Now when we run it, we should be able to see our sprites. Everyone should have their own unique sprites. But they will not be rotated, of course. Just got to wait for it to compile. Our game is getting much larger, so it's going to take a little bit longer to compile. Alright, and here we are. As you can see, they do have their textures with the big eyes and everything. Let's go see if the zombie textures are fine. That is pretty loud. I'm going to turn this down a little bit. There we go, and we have the zombie textures. So now everybody has their own unique textures. Now they just need to be rotated so that they're facing the direction that they are moving. And for our player, he will be facing the direction that he is aiming. Now to do that, we're going to need to enhance our sprite batch class. So let's go ahead and go into sprite batch. And so what we're going to need to do is, let's see, we have this draw function. Right now the draw function does not take an angle. So what we're going to do is add an overloaded version of the draw function that does take an angle. And let's actually add two overloaded functions. We'll do one that takes an angle and one that takes a vector direction, so that it's really easy for us to just pass in the direction that our units are facing. So we'll do float angle, and of course we will specify that in radians, not degrees. And for here, we're going to say const glm vec3 dir. So let's go copy both of these into the CPP file under the normal draw function. I'm going to type Control ML to close all of these. All right, and we'll put it under draw. All right, and now let's flesh these out a little bit. Luckily, they're going to be very easy functions. They're just going to call glyphs.emplaceBack with different constructors. So let's just copy these two right here. Now, just like we overloaded the draw function, oh, and of course we need sprite batch : just like we overloaded the draw function here, we're also going to need to overload the glyph constructor to be able to handle an angle. Now, right now, we only have one glyph constructor. It's in the header file. I'm going to go ahead and move this to the CPP file because we're going to have multiple constructors and we don't want to take up a bunch of space in our header. So let's change that to just the forward declaration for it, and we'll come into the CPP file, and we'll do this at the very top up here. I'm going to tab it back, and this should be glyph : glyph, and it looks like it's not going to let me actually tab it back, so that's not going to be in line with everything else. All right. Now this is our default glyph constructor, but let's add another glyph constructor, just one more, for a glyph with an angle, and this will be the rotated version. So we're going to go into the header file, we're going to copy it as well, and we're going to add float angle at the end. And we'll do that in the CPP file to this copied one. Now the reason I am making two separate ones is because actually specifying the angle and doing those cosine maths and all that, the trigonometry for rotating a point, isn't free. It's a little bit of an intensive math operation. Doing it a few times isn't going to matter, but if you have thousands of sprites, it will matter. So we only want to do that math when we have an angle that we want to specify. Otherwise, we're just going to use no rotation. So for instance, for our background sprites, we don't ever want to do a rotation, so we don't even need to use the rotation constructor. So that it doesn't have to do any of that math. But here, in the other glyph constructor, we are going to need to specify a rotation. Now, unfortunately, we can't just rotate the positions that we have set here with destination rectangle because they are not centered about the origin. Remember, our math rotates points around the origin. So what we actually need to do, let's undo all this. Actually, no, we should probably keep the formulas there. So what we need to do is, say we have a sprite out here. This is one of our player sprites or whatever. Here's this little circle, and that's his bounding box. Here he is out way far away from the origin. Well, to rotate him properly, we first need to translate him so that he is centered right about the origin. Then we're going to rotate him, and then we will translate him back to his original position. So to do that, let's create 4 vectors for the 4 vertices. So we'll say glm vec3, and we'll do top left, so TL for top left, and we're going to initialize that to half of the width in the negative x direction and half of the height in the positive y direction. So let's go ahead and create another vec2 here, and this will be glm vec2 half dimensions, so we don't have to do a whole bunch of divisions by 2. We'll say half dims. And that's going to be, for the x direction, that's dest_rect.z, which is, if you remember, the destination rectangle is a vec4 with x, y, width, height. So z is width. That'll be width divided by 2.0f for half width. And in the y direction, we're going to say dest_rect.w, and that is the 4th component, divided by 2.0f. So now we have our half dimensions. So top left is going to be in the negative x direction, so we'll say negative half dims.x, and in the positive y direction, so half dims.y. Then we need another vec3. I'm just going to go ahead and copy this 4 times. So we have top left, bottom right, and top right. So bottom left is going to be in the negative x direction again, and the negative y direction. And bottom right is going to be in the positive x direction and the negative y direction. And top right is going to be positive x direction and positive y direction. And what's the deal here? I don't think this is a... Oh, this should be a vec2, not a vec3. We are not making a 3D game, we are making a 2D game. Alright, so now here are our 4 vertices that represent our sprite centered at the origin. So now all we need to do is rotate each of these 4. So let's go ahead and create a function that will rotate a point. And we'll make it a private function of glyph. So it will return a glm vec2, and we'll call it rotate point. And it'll take a glm vec2 to rotate, and it'll take a float angle. So let's move this into the CPP file as well, under the glyph constructor. And we need to specify that it belongs to glyph. Alright, so now we just need to use our magic formula here at the top right. So let's make a return value. So we'll say glm vec2 new rotation, or new v for new vector. And we'll say new v, oh, and I didn't even name my vector here. We'll say pos for position. New v.x equals pos.x times cosine of angle minus pos.y times sine of angle. New v.y equals pos.x times sine angle plus pos.y times cosine angle. And then finally, we just need to return new v. Very simple little function. So now we just need to rotate each of these 4 points. So rotate the points, and we'll put a comment here. Get points centered at origin. So we're going to say TL equals rotate point TL times angle, or rotated angled radians. And we'll do that the same for all 4 of these. TL, BL, BR, TR. And we also need to add back the half dimensions, because whenever we treated the center of the sprite here as the origin, we kind of broke our usual convention of treating the top left as the position. So we need to make sure we correct that by just adding back half dims at the end of all of these. We just add back half dims. And now, finally, and this is TR, not RT, finally we need to use these 4 points to set the actual positions. So what we're going to be doing is using our desdirect.x and desdirect.y to translate them into their usual spots. So we're going to say desdirect.x plus tl.x for top left, and desdirect.y plus tl.y. And we're just going to repeat this process for all of them. So we'll say plus bl.x plus bl.y for bottom right, plus bl.x, br.x, don't want that, and desdirect.y plus br.y. And finally down here, desdirect.x plus tr.x, desdirect.y plus tr.y. Alright, and that will translate them all back, rotate them, and everything is awesome. So we now have the ability to specify rotated glyphs. However, we just need to be able to now use this other little formula up here for direction with our angles. So first, in the sprite batch draw function that specifies the angle, we can just go ahead and pass that angle through. However, in the sprite batch function that specifies a direction, we can't just pass the direction in. What we need to do is first compute the angle. So first, let's make a const glm vec2 right. This is the origin. Remember the vector that we are treating as the default rotation, which is to the right here, which is why I've drawn my sprites like this, all facing to the right. That will be a rotation of 0. And that's going to be the vector 1.0f, 0.0f. Remember, it needs to be a normalized direction vector. And now, what we need to do is just take the dot product of the direction. Oops, this should be a vec2. I keep thinking we're in 3D, but we are in 2D. So go to the header file as well and make sure we change that to a vec2. All right, and what were we doing? We were doing the dot product now. So it's as simple as saying float angle equals a cosine of, and we're going to say left, GLM dot of left and right. Oops, of right and deer. Now I may have gotten these two reversed, but it also may not matter. We'll have to see. So here's our angle. Now unfortunately, the way this dot product works is it's only going to compute the angle from the origin as a positive number, always in the same direction. Or it's always going to be a positive number. And what's going to happen here is if our rotation is actually, let's say we are rotated down here, it's not going to get this angle here. It's actually going to get this angle, which is a problem because we're always rotating in this direction. So we want this angle. And it's actually really easy to correct this. All we have to do is say if dir.y is negative, so if it's less than 0, if that's true, then we just say angle equals negative angle. And that will produce a negative angle that will rotate in the correct direction. And then finally, we just take angle and we pass it into our glyphs constructor. And that is it for rotations. It should all work now. We just need to be able to use it. So let's go into agent.cpp. Now I believe, so when we draw here, we're not specifying a specific direction for each of the agents. So let's go into agent.h and see if we even have, I believe we can just use the velocity vector for most of these. Alright, so let's go ahead and add a direction vector to the agent that we will compute in all of the update functions. Here we go. So we're going to say glm vec2 m direction. Let's go ahead and initialize that to glm vec2. We'll say always pointing to the right, 1.0, 0.0. That will be the initial direction. Now in the update functions for each of our different agents, we will compute their direction. So if we go to human.cpp, it's as simple as computing the, let's see, where are we doing velocity here? Position equals pos. Oh, that's the init function. Here we go. So direction, oh, he already has a direction vector. Alright, so we're just going to replace the direction vector in human with the one in agent. We don't need two direction vectors. So instead of direction here, it's going to be m direction, since we have changed our naming convention. And I know we have a lot of conflicting variable names here, conflicting conventions. Feel free to go through and change all those. M direction, M direction, M direction. And we're probably doing the same thing in zombie.cpp, so let's go there as well. And here we go. We actually don't use a direction vector here. So we're just going to say direction equals glm normalized instead of using a new direction vector. And we'll say m direction here. And then finally, we'll go into player.cpp. Does he have a direction vector? He does not. So here we go. We have mouse chords minus center position. And this only happens whenever he clicks. So instead, what we need to do is always be looking at the mouse chords. So let's go ahead and take this out of the current gun index thing here. We're always going to get those mouse chords. And we're going to take center position and direction out of that as well. And now we can, instead of saying vec2 direction, we're going to say m direction. Easy as that. Now all of our different sprites have their direction vectors being updated, and we should put m direction here. So now all that is left is to go into agent.cpp and pass that direction into spritebatch.draw. And that should be it. Let's go look here. I think there's, yeah, let's be a little bit efficient and let's make this a reference parameter so we're not copying two floats. It's a little bit of a premature optimization, but we're getting it for free, so it's not really a big deal. We did make it const after all. Put an ampersand in the header file as well. And now let's just run it and see if everything works. We may be slightly off on our rotations, or some kind of small bug may have messed up our vertices. We'll see what happened. Hopefully our offsets are all correct and everything's going to work just fine. Oh, and instead we get absolutely nothing drawn to the screen, so there's definitely something very wrong with our sprite batch rendering function. Give me just 1 second to figure out what I did wrong. So the bug was very simple. I just made the mistake of forgetting to change these after copy pasting. This is why copy pasting is so dangerous and you should never do it. So we have, instead of top left for all 4 of these, it should be top left, bottom right, top right. But when I was fixing this, I discovered something pretty funny. If you change this to bottom left as well, you get some pretty funny behavior. I'll go ahead and run it and show you what it looks like. Just thought it was pretty interesting. Everybody gets all warped and crazy just because one of the vertices is not rotating correctly while the rest of them are. If you play around with these parameters here, you can probably make some really, really nasty looking bugs. So I fixed that to BR. Now if we run it, it should work just fine. And let's see, and there we go. So now, as you can see, my little guy is always facing wherever the mouse is, and these guys are always facing the direction they're moving. And now the problem with their movement is quite apparent. As you can see, they jerk around a lot because they just kind of randomly change their movement. That's not very good AI at all. Instead, we should try to smoothly change their direction vectors whenever they're moving around. Same thing with the zombies. The zombies are always just going to face immediately towards their next target, which means they're going to kind of jump between different angles really quickly. As you can see, it doesn't look super great. Instead, what we could do is keep track of an old angle and a new angle and just kind of slowly interpolate between the 2 angles to make it much smoother. But that is outside the scope of this tutorial. I just wanted to teach you guys basic rotations so you could understand how to rotate things in 2D. In the future, we're going to be going over some 2-dimensional animation stuff with some sprite sheets, and we'll do some other cool stuff as well. Maybe we'll make some explosions or something cool. But we are nearing the end of this tutorial series. I'll probably do one more game challenge at the very end, and then we're going to be moving on to 3D games. So I hope you enjoyed this. I'll see you next time.